Welcome to the next lecture under the title of forming. In the last week, we saw bulk metal forming processes: rolling, forging, extrusion and wire drawing. These are the 4 processes which we saw in the last week. This week, our prime focus is going to be towards sheet metal forming process. Moment we say sheet, what all comes to our mind? 1. The sheet might have hole. The sheet might have shearing along the length. So, in this lecture, we will be more focusing towards these operations. When we talk about sheet metal, we also look at sheet metal bending process. When you have a car or when you have a bus, when you have a door or when you have any enclosure to be made, we always try to buy a sheet and then we try to bend. Moment we start bending it, you can also see there will be something called as spring back. Now, we should understand how do we reduce the spring back and achieve the exact cover whatever we want. So, sheet metal processes are going to be very, very important. In this lecture, we will first see sheet metal process introduction. Then sheet metal operations we will see, some of the important terminologies, other sheet metal operations, a small analysis from the material property towards the operation. It is very important because you should know what is the load I should apply, how thick should be my die, how thick I can try to take a material. All these things are analysis. Then drawing operation, we will look into analysis of drawing operation, then defects. Finally, we will do a small recap and references. This is a sheet metal process, wherein which we put a sheet and they are trying to bend the sheet such that they can create L type angle. Okay. So, it includes cutting and forming operation performed on relatively thin sheets of metal. We look at mild steel, copper, titanium, magnesium and many more things. Typically, what we talk is a range from 0.4 millimeter to 6 millimeter. Moment we talk about 6 millimeter, it is going to be a heavy force which is applied for doing any of these operations. Sheet metal work is predominantly performed at room temperature. The sheet metal parts are generally characterized by their high strength, good dimensional accuracy, good surface finish and relatively low cost. So, till now what we were only looking at it is bending. Now, let us try to see some new operations like stamping. The stamping is done in a press with the presence of a die. When I say die, there is a punch and a die. I hope you remember punch and a die. This is a punch. Right. So, punch and a die are used to perform the metal forming operations. The sheet metal products are called also as stamping products. So, what are the categories of sheet metal processes? One is cutting, bending and drawing. So, if you look at the workflow, you will try, this is the input which is given is a sheet. Then these are the operations which are done on the sheet. Shearing, slitting means breaking, right, 2 pieces, then cutting, the difference between slitting and cutting is, cutting you can do for a little larger width, slit is for a small width. Then you can also have sawing, slitting, sawing, cutting. These slitting and sawing predominantly can be done on a rotatory tool or a circular disc like thing. But all these things are basically operations which are carried out on the sheet metal such that they try to give an output. For doing these operations, we are trying to have these machine tools, and we also try to have some tools. So, these are the operations, these are the processes. Okay. For doing these operations, we can come out with the process. So, punching is one process, blanking, fine blanking, stamping and embossing. When we try to look at the other spectrum, so here we have bending, roll forming, stretch forming, deep drawing, rubber forming process, spinning, superplastic deformation, pin forming, explosive forming and magnetic pulse forming. So, here they are bend, right? They are bend and they try to deform. Here they cut and they remove the waste. So, these are operations which are done using a punch, die or a compound or a progressive die. Once the operation is over, we have to do a post processing operation which can be either deburring, cleaning or coating. So, these two are the processes which we will see in detail. Bending and drawing are used to form sheet metal parts into a required shape. So, all these things are forming process, right? And here if you see, these things are cutting process. Cutting, shearing, slitting, all these things come here. So, cutting operation. Cutting is used to separate a large sheet into small pieces. You cut into small pieces. You take a vegetable, cut it into small pieces. So, cutting is used to separate large sheet into small pieces. To cut out part perimeters and to make holes in parts, we try to do this cutting operation. It is accomplished by a shearing action between two sharp edges. So, here is a sharp edge, here is a sharp edge. So, here what happens is the shearing action. So, this is a punch, the punch comes with a certain velocity, it can be gradual, it can be impact. Okay. It can be mechanical, it can be hydraulic. The punch moves up and down, there is a die, in this there is a sheet metal which is placed, right. So, now the punch is moved downwards. So, there is a die sheet metal. So, once the punch is moved downwards, there is a plastic deformation which is happening. Because of initially they start with the plastic deformation, then further penetration happens. So, that leads to a fracture. So, the cutting operation is accomplished by a shearing action between two sharp edges. So, the important terminologies when you try to shear, you can see these are the terminologies: rollover, burnish, fractured zone and burr formation. Rollover, at the top of the cut surface is a region called rollover. This corresponds to the depression made by the punch in the work prior to cutting. So, initial indentation is nothing but rollover. Burnishing means where there is a smooth region, it results from penetration of the punch into the work before fracture begins. So, burnishing means you are trying to roll the material along the walls, that is burnishing. Rollover is the initial bend whatever you create. Then comes fracture zone. In fracture zone, it is relatively rough surface of the cutting edge where continued downward movement of the punch causes the fracture. So, here rollover, then it is burnishing, then here the fracture starts. Right. After the fracture starts, any excess material which comes as projecting out of the surface is called as the burr, which has to be removed. If you try to slide or touch and feel just on top of a hole which is made on a metal sheet, you will always see there are sharp edges. Those sharp edges are called as burrs. So, when we do a cutting operation, these are the terminologies which are formed when we try to take a cross section and look at it: rolling, burnishing, fracture zone and burr formation. The first operation what we saw was cutting. Now, what we see is shearing. So, shearing. So, this is the die, and here you can see there is a punch. This is the side view and this is the front view, same. Right? So, you see here there is a taper. So, shearing is a sheet metal cutting operation along a straight line between two cutting edges. Shearing is typically used to cut large sheets into small sections. So, you can see if you have a large plate or a large sheet, you want to cut it into several small segments, what we do is shearing operation we do. Okay. It is performed on a machine called as powered shearing or square shearing. This is always taper. Why is it taper? Because when we always start at one edge where it is called as the first approach edge. The first approach edge, you will have a sharp corner, and this sharp corner, if you see the stress which is getting generated, it is force per unit area. Area is very small. So, force will be very, whatever is the normal force, the stress will be very high. Because of the stress, what will happen? The initiation of the crack or initiation of the shearing can start, and after which you are trying to go all along the length before it finally shears. So, the shearing we will always have a taper. It is very important, and if you have a very thin punch, then this will lead to bending. In order to avoid that, what we do is we try to have this taper edge and a thick plate. Next operation is blanking. Blanking means, so you have a strip, you have a punch, you cut a portion of the punch, right? You cut the portion of a sheet, and what comes out is called as a blank. Now, this blank will be the useful part for further operations. Right? So, blanking involves cutting of the sheet metal along a closed outline in a single step to separate the piece from the surrounding stock. So, this is the stock. So, this if you see initially, it will be a sheet of a thin sheet of metal. So, now with the punch you try to blank and get the piece. So, now this blank is the starting material, or this is the work which can be further used. The part that is cut out of the desired product in the operation is called as the blank. Punching. So, whatever comes out of the sheet is called as the blank. So, now in this blank, if you want to make a hole, it is called as punching. Punching is a similar operation to blanking, except that it produces a hole and the separated piece is a scrap or a slug. In the first one, whatever came out is called as a blank, which is a useful part for the next operation. In punch, whatever gets punched out is called as a scrap or a slug which is there, and you try to create a profile. The remaining stock is the desired part. So, now I am sure you will be able to distinguish punching, blanking, shearing also. So, we have parting operation, parting, slotting and perforation. So, these are hole perforations. Suppose you wanted to sort coins, so then they will have varying diameter, or you wanted to sieve some ore. So, they have a sheet sieve, right, of a larger diameter hole. Parting operation, it involves cutting a sheet metal strip by a punch with two cutting edges that match the opposite sides of a blank. So, this is called the parting operation. So, you have a blank, this is a scrap. It involves cutting a sheet metal strip by a punch with two cutting edges that match the opposite side of a blank. What is a slotting? A special type of punching operation is called as a slotting operation. Here in punching, generally what we do is we try to have a circular hole. In slotting, we have a square or a rectangular hole. Perforating, it involves simultaneously punching of a pattern of holes on a sheet metal. The hole pattern is usually used for a decorative purpose, or it allows light, gas or fluid to flow through it. It can be used like a sieve. Notching operation, it involves cutting out a portion of the metal from the side of the sheet or a strip is called as notching. This is called as notching. Right. Trimming is a cutting operation performed on a formed part to remove excess material and establish size. This is trimming. So, notching is on the side, if you try to remove material, is called as notching. Trimming, it is a cutting operation performed on a formed part. Please understand, this is on a formed part to remove the excess metal and an established size. Trimming is you take a scissor and cut, that like trimming, right. The barber does trimming operation, cutting of the excess metal from the manufactured part is trimming. Shaving operation, this is a shaving operation. Shaving operation means it is a secondary shearing operation performed with a very small clearance to obtain the accurate dimension and the cutting edge that of a smooth and a straight one we call shaving, right. Shaving is removing the excess material little bit to get, it is called as shaving. The secondary shearing operation performed with a very small clearance is shearing operation. Now, let us do a little bit of analysis in sheet metal. So, this is the punch, this is the die, okay. This is the sheet metal where we keep. The punch moves downward. When the punch moves downward, it tries to do whatever operation we said, the 4 operations, shearing, fracturing, all these things happen, and then it brings out the blank piece. If the blank piece is further used, this becomes a blank, or if it is a scrap, then it becomes a punch, right. So, here what you have is a diameter, which is the punch diameter. There is always a clearance between the punch and the die. So, that is called as C, a clearance. So, if you see the die size is DH plus 2 times C will be DB. Die size will be large. Why? Because as and when you punch, the part has to fall down without any clogging. So, it will push itself and then it will fall down. So, this is die size, this is punch size, die size and punch size, and between the die size and punch size you always will have a clearance. The process parameter in sheet metal cutting are clearance between punch and a die, which will be the clearance will somehow have a relationship with respect to the sheet thickness or the stock thickness, type of metal, its strength and the length of the cut. So, what is clearance? The clearance is C in a shearing operation is the distance between the punch and the die. It usually ranges 4 to 8% of the sheet metal thickness. So, the clearance will be 4 to 8%. So, which is AC into T. So, AC is the clearance allowance, T is the stock thickness. So, clearance C will always be taken. The clearance allowance depends on the type of metal. Punch and a diameter. The punch diameter, the blanking punch diameter will be DD minus 2c. The blank diameter will be dd. The punch and the die size for a round hole of a diameter dh are determined as the hole punch diameter is dh and the hole clearance will be dh plus 2c. Please make a note for blank what is it and for a punch what is it. In the examination, you can be asked a problem based on this. So, blanking punch diameter will be die size minus 2c, whereas in the punch size it will be hole diameter will be dia of the hole plus 2c. So, if we want to find out the force which is required for shearing, so that will be figured out from S into T into L. What is S? S is the shear strength of the given sheet material, T is the thickness and L is the length of the cut. T is the thickness, this is T and this is the length of cut edge. An angled cutting edge on the punch or the die reduces the maximum cutting force. Bending operation. Bending operation you can see when you try to buy any vessels, there will always be bending at the top, right. So, that is bending operation. You can even try to see when you take a milk kettle or a milk boiling vessel, you can see they will always have a mouth which is rounded off. All these things are bending operation. When we try to have a rod, we also try to bend the rod. So, here we are talking about sheet, when you can also convert the sheet into a rod, then we do call bending of rods. Bending in the sheet metal work is defined as the straining of the metal around a straight axis. So, this is the straight axis, neutral axis. During the bending operation, the metal on the inside of the neutral plane is compressed. So, this is compressed, inside is compressed, the outside will be tensile, while the metal on the outside of the neutral plane is stretched or tensile it undergoes. So, when we try to bend, compression and at the top it will be tensile. The bending produces little or no change in the thickness of the sheet. So, when we try to bend, it has to bend in such a way there is no the thickness, this is the thickness, this is the thickness, the T will be uniform all around. Okay. So, this if you look into it, this is a sheet metal, this is the neutral axis, it is stretched in the top, compressed in the bottom, and then when we have to bend it, it has a radius, you will not have a sharp bend. So, you will always have a radius of r and the neutral axis will be bent by an angle called alpha. This is alpha dash and this is alpha. So, bending we can do V bending, we can do edge bending. V bending is when in a V bending the sheet metal is bent between a V shaped punch and a die. This is a die, this is punch. So, when it press, it tries to make a V shaped component. It is gradually used for lower production process. When we go for edge bending process, edge bending like in the glass tumbler edge, it involves cantilever loading of the sheet metal. The edge is generally bent at 90 degrees, bent to 90 degrees or less. So, bending greater than 90 degrees can produce a wiping die, can be produced by a wiping die. So, if you want to have more than 90, it will have a wiping die. There has to be a change in the die. So, flanging, it is a bending operation in which the edge of a sheet metal part is bent at a 90 degrees angle to form a rim or a flange. This is a straight bending, this is stretch bending and this is shrink bending. So, stretch bending is along like this, shrink bending is along in this direction. Straight is this way. So, straight and then here you will have a stretch like this and the other way around is you will have a concave and then you will have bending. So, this is often used to strengthen or stiffen a sheet metal. Hemming. Hemming is bending, again it will try to increase the stiffness of the sheet metal. It is involved in bending the edge of a sheet over on itself in more than one bending step. So, we try to do this because if you want to increase the stiffness, we try to do. This is often done to eliminate the sharp edge on the piece. Seaming is connecting two sheets. It is an operation where two sheet metal edges are assembled. It is almost like this. This is one hemming, this is another hemming. These two hemming put together is called as seaming. Curling is the other operation. So, curling is you try to bend and create a curl. So, it is also called beading. It forms the edge of a part into a roll or a curl. This one is hemming, then it is seaming, attaching two things, and then it is bending and then you leave it. You also have several of these bending like channel bending. You can bend and create a long channel bending, and then you can have U-channel bending, U-bending. Then we have a air bending, so wherein which you have a small bend like this. Offset bending is possible, like corrugated sheet you have. Then you have corrugating, which is also a bending operation. Then you have a tube forming operation. Tube forming is you start like this, you press it, then these two fellows join together and it forms a tube. Okay. These are the other bending processes which are generally done on a sheet metal process. Now, let us try to understand the important concept in sheet metal called spring back. Why is this spring back coming into effect? Because when you try to see the stress strain curve, it has elastic, then maybe it gets into a plastic region. So, this is elastic region, this is plastic region. When we try to deform plastically, at certain point what happens is, if you are not properly into the plastic region, there is always a small amount of recovery happens in the plastic zone that leads to the spring back. When the bending pressure is removed at the end of the deformation process, elastic energy remains in the bend part, causing it to recover partially towards its original shape. This elastic recovery is called as spring back. It is also defined as the increase in included angle. This is the included angle alpha, included angle of the bend part relative to the included angle of the formed tool after the tool is removed is called as spring back. Spring back is nothing but you have alpha dash minus alpha b dash divided by alpha b dash. So, this is the angle whatever it is getting formed, and when the punch is removed, you see here this will try to change or increase by this. So, the difference divided by the original will try to give the spring back. The included angle of the sheet metal part in degrees is alpha. This is alpha, right? This is alpha. Then included angle of the bending tool degree is the alpha b. So, the difference between these two is called as the spring back. It is a very important phenomena. Whenever there is a bending operation, there is a elastic energy recovery that will try to bring it back to the original shape. What is the original shape? Original shape was a flat plate. Now, you are making it into V. So, now what will happen? It will become like this. So, this is what is the tool, the punch angle, whatever it is, and this is what after it is removed, it tries to take. So, bending force, how do you calculate the bending force? The bending force can be required to perform bending depends on the geometry of the punch and dry, the thickness and the length of the shear metal. So, it will be force is equal to tensile strength into width of the part into thickness of the part divided by die opening dimension. This is a constant which depends on the type of bending. So, force is equal to Ts. Generally, what we do is Ts into 2 by d, and this is something like a weightage factor. D is the die opening dimension. Die opening dimension. This is d. This is d. Die opening dimension. Okay. So, width of the part or width of the sheet. Drawing operation. Till now, what we saw was various cutting, shearing, bending operations, right. We also saw a blanking operation, we also saw a punching operation. Now, what we will do is we will get into a process called as drawing. In drawing, what we do is we always look for high aspect ratio parts. So, wherein we try to talk about diameter of the blank. What is a blank? Sheet metal. You had a punch, you pressed it, and what fall down was the blank. Now, using this blank, you are trying to push it against a punch which moves into the die to create high aspect ratio parts. So, here the diameter to depth matters. Okay. So, here this is what is drawing operation. In drawing operation, we always try to make a glass tumbler, a vessel, deep drawing. It is performed by placing a piece of a sheet metal over a die cavity and pushing it as against the punch. Now, wherever when the punch comes down, the punch is now rounded. So, in the shearing operation, we had a sharp edge. So, this sharp edge was at an angle. So, it created piercing, right. But here what we do is we have a radius. Moment you have a radius, then what happens? It will not try to puncture or shear, it will try to push it down and bend the blank as and when it goes down. So, it is used to make cup shaped, box shaped or other convex or concave shaped parts such as beverage canes are made out of drawing operation. Pepsi canes are made out of drawing. Then ammunition shells, then sinks, cooking pots and automobile body parts are all made out of drawing operation. Okay. So, here there is no cutting of the blank, it will be just bending along it. So, here there is a radius, the die also has a radius. So, this radius allows it to smoothly flow and then it tries to create a. So, this is how it is, cup. Okay. So, these are the steps which are involved in a drawing operation. In drawing operation, first is drawing is a complex operation which involves multiple stages. In the initial stage, what we do is we try to have a blank holder, which I did not tell in the previous slide, blank holder. So, now the function of the blank holder is to hold the blank. What is the blank? The yellow part is called as the blank. This is the blank. Why is this blank required? Suppose if you do not hold the blank and when you try to do a bending operation, then there can be wrinkles which are formed on the edges. So, in order to avoid and to have a proper flow of metal as and when the punch moves down, we have a blanking force. Optimizing the blanking force, the blank holder's force is very, very important, which is in turn related to the velocity with which you push it down. So, initial stage is that. Then in the next stage, there is a bending which happens to the blank. So, the holder continues to have the same force. Now, the punch is moving down. So, it tries to create a bending operation. As and when it moves down, this bending will try to convert into straightening, and this is a constant volume process. The material has to flow from the blank area only. So, it will have a straight portion. Then after it has achieved the straight portion, then what it will do is it has friction and compression, you further move it down. In reality, it is a constant blank holding force, but if you want to get the best out of it, you can also have a dynamic blank holding force. That means to say, depending upon the punch height moving down, the velocity with which it is moving down, the material which is flowing, the speed with which it is flowing, you can try to also vary the blank holder force. Generally what we do is we try to have a load and then we will try to have a spring, or we will have a nut and then nut to tighten this. That is how we do it. So, you can have the friction and compression happens when it goes to the final one, and finally what happens, all the material below the blank holder is eased out and then you create a straight wall. So, this is called as the final cup shape, showing the thinning into a cup wall. So, all these things are different steps of drawing process. It undergoes all these things. Bending. So, if you go back in bending, you see what all did we see in bending? We saw flanging, V-bending, edge bending, flanging, hemming, seaming, curling, all these things are bending. Here also it is bending. So, bending means there is no cut, it is only trying to change its shape from flat to a cup. So, here we will try to do a drawing analysis. In case of drawing a cup shaped part, see, you cannot have the punch diameter equal to die diameter. If these two are equal, then whence it is bending, so you will not have enough space for the blank to bend. So, there is always a clearance which is given. So, C is the clearance which is given, and the blank diameter is, this is the blank diameter which is dB. The punch diameter is called as dP. The die corner radius, this is called as the die corner radius is called as the RD. The punch corner radius is called as RP. The force which is required to push it down is F, and the holding, blank holding is this. If the holding is very tight, when the punch moves very fast, it can shear. If the holding is very weak, when the punch is moved down, you will try to have defects in drawing. So, the clearance is always given as 10% greater than the stock thickness. So, C will be 1.1 times the thickness. The drawing ratio, which I told you as the aspect ratio, it is defined as the ratio of blank diameter, which can be written like this, dB to dP. Greater the ratio, more severe is the drawing operation. So, we try to do this. Today what is happening, so we can also have lot of water which is getting filled here, and you try to press. So, there is a hydrostatic pressure which is getting applied to the blank. So, because of that you get a better stretching. So, better stretching means higher drawing ratio. The limit of dr is always equal to or lesser than 2, depending on the punch and the die corner radius, friction condition, draw depth, the quality of the sheet metal like ductility, degree of direction of the strength, directionality of the strength properties in a metal, we try to have the drawing ratio. So, there is something called as reduction. Reduction in the drawing can be written as blank diameter minus the punch diameter divided by the blank diameter, which is always equal to less than or equal to 0.5. The thickness to diameter ratio T by T, T is the, this is T. The thickness to diameter ratio of the blank is T by dB, is the ratio which should be always greater than 1%, is less, then the tendency of wrinkling happens. Wrinkling is a defect. We will see wrinkling as and when we move forward. So, the drawing analysis is F is nothing but pi d diameter of the punch, thickness of the sheet into ultimate tensile strength multiplied by a ratio which is, or a correction factor, the diameter of the blank divided by diameter of the punch minus 0.7. So, through this what we get is the force. So, the holding force, this is the holding force, this is the force with which the punch is moving. The holding force is equal to 0.015 times sigma yield strength pi into, this is a factor, and there is approximately 1/3, approximately holding force is 1/3 of the drawing force. This and this is 1/3. So, this is drawing. You can also have redrawing. Redrawing means you try to generate a cup and then next you put one more step and then you try to create a drawing. So, in some cases the final shape of the part requires more than one drawing step. First you created this, then you created this. Right? The second drawing step or any further drawing step, if needed, are referred to as redrawing. The maximum you can draw in one step is 40 to 45% only. Right? In the second drawing you can go 30%, in the third drawing you can go 16%. Why is the drawing the percentage of drawing goes down? Because more and more strain hardening happens. Because of the strain hardening, it can go down, the percentage goes down, the maximum reduction percentage goes down. Reverse drawing is also possible. Redrawing and reverse drawing are different. Redrawing means in the same side, if you move the punch down, is called as redrawing. In reverse drawing, what we do is we bend it in, we draw it in one direction and then we flip it off, place it in other, and then we try to push it down. So, in this process, a drawn part, this is a drawn part, is positioned face down on the die, so that the second drawing is complete in the direction of the initial bending. So, initial bending it is done. So, redrawing and reverse drawing are different. So, now let us see drawing without a blank holder. If there is no blank holder, the aspect ratio will be reduced and the thickness variation along the drawing can be there. So, that is the problem when we do without a blank holder. Drawing without a blank holder prevents wrinkling of the flange while the cup is being drawn. See, why is that wrinkling coming? We will see wrinkling later. Once there is a restriction here, so moment there is a restriction here, there is a restriction for flowing, but the material is trying to flow, there can be a tearing, breaking, or there can be a loose edge forming on the top surface. So, the tendency for wrinkling is reduced as the thickness to diameter ratio of the blank increases. The T by dB ratio is large enough, the drawing can be accomplished without a blank holder. So, the limiting condition for blank without a blank holder will be dB minus dP, diameter of the die minus diameter of the punch, which is lesser than 5 times thickness. Ironing can also be there. Ironing means the reduction in thickness can happen. It makes the cylindrical cup more uniform in the wall thickness. So, when you move down in ironing, you will get a uniform thickness. Lancing is an operation which is also done. Lancing is a combination of cutting and bending or cutting and forming operation performed on a single step to partially separate the metal from the sheet. So, what you do is you try to cut it and then you try to bend it. So, that is lancing, a combination of cutting and bending or cutting and forming operation in one step to partially separate the metal from the sheet is done as lancing. Embossing, embossing is basically to increase the surface area. So, this was a flat plate, now you have bumps on it, surface area is increased. It is a forming operation used to create indentation in the sheet just by rising, lettering or stretching ribs. So, it is basically to increase the surface area. So, if it is a smooth sheet, you might slip. So, if you have this embossing done, so it increases the friction and you will not fall down. So, this is what I was trying to tell you about wrinkling. Wrinkling means something like making a frill around the flange. This is called as the flange surface, flange. When you have a blank, when it is bending, this becomes a flange. Wrinkling in the flange, drawn part consists of a series of ridges that form rapidly in the undrawn flange of the work due to compressive buckling, right. So, because of this wrinkling happen, the material flow will not happen uniform. Tearing means whence you are trying to push the punch to a far extent and you have hit the limits or there is not much of material to flow. So, there comes the tearing. It is an opening crack in the vertical wall, usually near the base of the cup, is called as tearing. Earring means here you don't have a straight on top, you will have something like a ear which is created. It is the formation of irregularities in the upper edge of the blank or the flange, deep drawn cup. Then surface scratches. Surface scratches are, there are friction which comes into existence, and if there is improper finish of the die and the punch, whatever it is, it tries to create scratches which increases the friction. So wrinkling, this is the first step, wrinkling, this is the second step. So you have compressive buckling happens, you further push it down on the edge, top edge of the cup, you will see undulations. Sheet metal dies. Stamping die is used for stamping. So stamping is a process. Stamping means like you have a stamp, you create an emboss, or you have a stamp, you try to create a hole, a blank or a punch, right. Stamping die is used for higher production. So what happens in stamping? You punch it once, when you take it up, it advances, then you punch it, it advances, something like that. Stamping die is used for higher production in sheet metal working. These stamping dies are generally made out of tool steel. The stamping die, there are several varieties of stamping die. It is simple, compound, combination and progressive die. Progressive die are progression, one after the other after the other. Two or more operations on a single metal coil at two or more stations is called as progressive. Right. Simple die, it is simple, punch comes down, the blank or the punch, the slug which falls down, simple. Two operations at one time, if you do, it is called as compound operation. Two operations at two different stations, it is called as combined die. Compound die, combined die, two different things. Please understand the distinction between these two, very important. Combined die is two operations in two different stations, first station, second station. First station you try to punch, next station you try to bend, or first station you try to cut, next station you try to bend, right. So those things are called as combination dies. Compound dies is in the same, that means to say you have a redrawing, right. So you have a draw, first draw made, and then you have a second drawing, that is compound die. So these are the different types of stamping dies which are available, and they are all used for increasing the production rate. So this is a progressive die. Progressive die, you have a upper shoe, you have a lower shoe, right, and then you have punch, strip. What is progressive die? Two or more operations on a sheet metal coil at two or more different stations is called as progressive. So the strip developed in progressive, you can, this is the finished part, this is the starting part. So first you do parting, then you do punching, then square punch, then semi notch, then strip notch also you will try to make. So these are all progressive, one after the other, after the other, after the other. So these are the different types of stamping press components machine. There is a fly weight which stores the energy, and then there is an impact load which comes. This is a gap frame press. This is a press brake which is hydraulic operated. The other metal forming processes are stretch. So stretch, what we do is we try to have a blank, we try to hold the blank on both sides, then we try to have a die which has something like a conical shape. So now when this is pushed, it tries to stretch the sheet metal. Stretching is important because you are trying to strain harden the material. Stretching forming is a sheet metal deformation process in which the sheet metal is intentionally stretched and simultaneously bent in order to achieve the shape. So stretched, so basically what they do is they try to stretch and they try to bend. This is bending. Okay. So the work part is gripped by one or more jaws on each end and then stretching. Then the stretching happens, then the bending happens. So this is stretch forming process. Roll forming process is also there, is a continuous bending process in which the opposing rolls are used to produce long sections of formed shape from coil or strip. So it starts from here, then it forms a long strip, right. These are side views, and then you have the V, which is the roll. These are the rolls, and here what we do is we try to give a coil or a strip. Roll bending, Suppose you have a flat plate, I then have to make a shell. They use it as roll bending. For example, if you see all the HPCL, BPCL, IOCL, huge oil tanks where they store petrol, diesel and all, they are all large diameter one. So, these large diameter structures are made by roll bending. So, what they do is they push a sheet and then they have two rollers, then they have one roller in the opposite direction. It goes back and forth multiple times and then finally it forms a ring or a circular radius thing it forms. So, it is an operation in which large sheet metals or plate metal parts are formed into curved shapes to meet out to the requirements. So, roll forming and roll bending are other operations which are used there. Spinning, almost all the vessels are made out of, vessels and artifacts are made out of spinning process. In spinning process, you keep a blank, then you clamp it, you use a tool which pushes the blank as against the mandrel. So, it tries to get the shape of it. It is almost like your deep drawing, but here there is no blank and it is spinned on top of a mandrel. Right. So, it is a metal forming process in which an axial symmetric part is gradually shaped over a mandrel to form by means of a rounded tool or roller. So, this is a rounded tool or roller, no cutting or something. The tool or the roll applies a very localized pressure, deforms the material to meet out to the requirements. Explosive forming. In explosive forming, it is very simple. We have a sheet which is there and then which is placed against a die. Then we have an explosive material. We try to explode it. When the explosive material is exploded, it creates lot of shock waves. These shock waves are used to form as against the die. Many of the dissimilar joining of sheet metal, if you want to have bimetallic metals, we do it by explosive forming. So, explosive forming involves the use of an explosive charge to form a sheet metal into die cavity. The work part is clamped and sealed over the die. The work part is clamped and sealed over the die and a vacuum is created beneath. So, that when the explosive die form is there, you try to remove the vacuum, you try to get the shape. The apparatus is placed in a large vessel of water. Right. An explosive charge is placed in the water at a certain distance from the workpiece. The detonation of the charge results in shock wave whose energy is transmitted through water to cause a rapid forming. Any complex shapes it can do and any dissimilar material joining it can do. So, before we do recap, let us try to do some experiments. You try to take a rod of steel and bend rod of diameter 4 millimeter and bend it to any shape, bend. Take a wire, aluminum wire, and try to bend in the same shape, in the same shape as one, whatever it is you did for rod, right. Third, try to take a steel sheet, and maybe here wire, when I said it is 1 millimeter, sheet you try to take maybe again 1 millimeter and bend as the same shape as above, right. So, now you will see when you bend it and then you draw the profile on a A4 sheet and leave it there for 24 hours. You will see there can be a spring back happening, So, you will note down, do the experiment for all the three: sheet bending, wire bending, rod bending, and then you will try to mark So, if you find this is too heavy for you, you can try to take 2 millimeter, bend it and make a shape and then leave it. So, record the spring back for all these 3 materials. Now, look at the mechanical property and see is there any relationship with respect to bending you have done. And here what are we interested? Spring back, to find out what is a spring back. Next is we would like you to take two sheet of 0.4 millimeter sheet, right, of any alloy same, and try to do a hemming operation. Hemming, and then you also try to do locking. See how easy or difficult it is, right. So, if you try to do some of these experiments, you will be easily able to understand what we studied and how difficult or easy is it. So, in this lecture, what did we go through? What is sheet metal process we saw? Various sheet metal processes: blanking, punching, shearing, cutting, drawing, right. These are some of the operations we saw. Then we saw forming also. Important terminologies with respect to die we saw. Other sheet metal operations we studied. And for 2 of the processes we saw the metal analysis in trying to find out the force required for cutting, shearing or deformation. Then drawing operation, analysis of drawing operation, wrinkling, defects like wrinkling, tearing, scratching, all these things we saw. For preparing the slides, we have referred these books. Thank you so much.